So today's topic is 3D IC and chiplet. So let us see the next revolution in semiconductors technology. So coming to the introduction, let us know what is the difference, what is the actual 3D IC and the chiplets mean. So 3D ICs, which means 3D integrated circuits, stack multiple, which they are connected as stack multiple layers of silicon dies vertically. So connected using to silicon vias, that is called TSVCs, enabling higher performance and reducing the power consumption. So coming to chiplets, modular semiconductor blocks that can be mixed and matched on an interposer or substrate, so which improves the yield, cost efficiency, and the design flexibility. So let us check what are the key differences and the benefits between the 3D ICs and the chiplets. So coming to the integration future, 3D ICs are placed in vertical stacking. Chiplets are based in horizontal or 2.5D integration. So coming to interconnections, like it is of a hybrid bonding, and in chiplets they uses UCIEs, EMIBs, etc. So coming to use cases, 3D ICs can be used as HBM processors, and chiplets can be used as heterogeneous integration. So which is the combination of all the three, like CPU plus GPU plus AI. So this is the key difference. So let us check the benefits of chiplets and 3D ICs, so which gives the higher performance and bandwidth, and it reduces the power consumption, which improves the yield and cost efficiency, and it is a faster time to market and ready for tape out. So let us see what is the evolution from 2D to 3D ICs and the chiplet based design. So coming to 2D scaling limits, so it explores about the Moore's law, which slows down due to the physics or physical constraints. So coming to 3D ICs and chiplets, so which enables the continued performance exponentially, which gains through advanced packaging. So let us check the what are the key milestones here. So at 2011, so Xilinx introduces the 2.5D ICs with interposers. In 2017, AMD adopts the chiplet design in EPYC processors. In coming to 2022, the Universal Chiplet Interconnect Express standard has been launched. So where the UCIEs had been launched. So coming to 3D ICs technology. So let us check the type of 3D ICs and how they work. So the first type will be monolithic 3D IC. So which is being built layer by layer on a single wafer. So stacked 3D ICs, so it builds multiple dies beyond the vertically. So coming to 2.5D ICs, so here the dies are placed side by side on an interposer. So the next type will be through silicon vias and hybrid bonding. So through silicon vias, that is CSVCs, here the connection is between the tiny vertical interconnects which passes through the silicon layers. So coming to hybrid bonding, so there is a direct copper to copper bonding for ultra fine pitch interconnects. So examples like AMD and 3D VCatch. So coming to thermal and manufacturing challenges in 3D ICs, so there are the challenges like heat dissipation, so where the stacked layers increase the thermal resistance, and stress and warpage, where the TSVCs induce mechanical stress. So coming to yield and testing, so complex assembly increase failure risk. So this is about the 3D IC technology. So let us check the chiplet architecture. So coming to know, so what is chiplet? So definition, so it is small specialized die which is integrated into a single package. So coming to its advantages, so it has the mix and match IP blocks like a CPU, GPU, and AI accelerators. So it has the better yield, and it is very cost effective scaling, so which can be used for reused for validated chiplets. So this figure shows the chiplet architecture, so which consists of the white box along with mux, buffers, samples, and hold times, so shift registers, adders, so which have been placed and shown in the figure. So coming about the chiplet interconnect technologies, so UCI is Universal Chiplet Interconnect Express, so which is an open standard for die-to-die communication. The next Intel Foveros, so which is a 3D stacking with face-to-face bonding. So EBIMB, so embedded multi-die interconnect bridge, so which gives the high density interconnects without full interposers. Let us check the challenges in chiplet based design. Standardization. So UCIS aims to unify interfaces. So signal integrity, which is a high speed interconnects and requires low latency. Coming to the testing and reliability, ensuring the compatibility across the vendors. So this is the challenges in chiplet based designs. So coming to what are the industry trends and applications. So coming to the case studies of companies like AMD, Intel, Nvidia, Apple. So we can look where the Gen CPUs and 3D cache memories are used in AMD, and Meteor Lake is used in Intel, so which is a tile based chiplet design. So in NVIDIA here we can use the Grasshopper superchip, so which consists of CPU plus GPU along with the NVLink. In Apple, they use M series chips, so which is used for advanced packaging for unified memory. And in real world cases, we can use like in AIML, HPC, 5G automotive, so where it transfers the data very faster between CPU, GPU, and accelerators, and it is a heterogeneous integration for power efficiency even. These are about the industry trends and applications. So let us check what is the future of 3D ICs and chiplets. So the future is driven for a backside power delivery and advanced backing, so which reduces the interconnect resistance, and it had been co-packaged like a wafer scale integration, and AI for EDA. We can use the machine learning and optimize the 3D placement and routing for back-end development. And usage of this quantum and photonics, which is being integrated with the silicon-based chiplets. So this is about the future. So let us conclude the topic 3D ICs and chiplets are redefining the semiconductor design which have been pre-existed and enables the continued innovation beyond the Moore's law. So with advancements in packing, interconnects, and AI-driven design, so the future of computing will be very faster when compared to previous one, and it is a more efficient and highly customizable. So this is about the 3D ICs and chiplets. So